Chapter 14, Multivibrators and the 555 Timer. Multivibrators change between two digital levels, continuous and free running. They are on demand as well. There's three types: bistable, which is the SR flip-flop, astable, and monostable, which is a one-shot deal. The capacitor charge and discharge rates for these devices uses an RC circuit. This circuit has a charge curve and a discharge curve. As shown here, you have a charging path to the capacitor and a discharging path, depending on where the switch is located. You have your VC versus time graph with the charging curve, and the VC versus time graph with the discharge curve that discharges and charges at an exponential rate. This is the equation to find out the time it takes to charge and discharge. You end up with T equals RC, the resistor value, versus the capacitor value, times the ln of 1 over 1 minus the voltage change over E. Astable multivibrators, the single Schmidt inverter and an RC circuit. This also has a charge and a discharge function. Monostable vibrators. These are shown here with the simple one input trigger pulse and a Q and a Q naught. They're built from NAND gates as shown in figure 14-9 right here, with two NAND gates following. The output of NAND gate 1 goes into the input of NAND gate 2. An IC monostable vibrator is an example is the 74121. It's non-retriggerable. It can connect RC components for a proper pulse width, and it's two active low trigger inputs and one active high trigger input. This is shown here with your A1, A2, and your B inputs going through the Schmidt trigger and the RC timing, and your outputs follow. This is shown also in our truth table for this circuit. Retriggerable monostable multivibrators. The 74123 is a new timing cycle each time new trigger is applied. This is a comparison waveform for this, showing the triggers changing and the non-retriggerable output, and the retriggerable output as well, flipping the same amount of time per the trigger. This is a truth table for the logic symbol and function table of the same retriggerable monostable device. And this is a curve showing you with different resistor values how the performance of the output pulse width versus external timing capacitance is for each different resistance used in the timing for the circuit. Astable operation of the 555 timer. It's a one-shot or astable oscillator. It can be used as a voltage divider or comparator, an SR flip-flop, and it discharges transistors. This is an example of a simple 555. You have your charging path and your discharging path. Again, this creates your oscillation with your 50% duty cycle astable oscillator, and you have it going right into the 555 timer. It uses a 0.01 microfarad capacitor with your discharging path with your diode acting as a short with RB. And this is your monostable operation of your 555 timer. And we can also use crystal oscillators, which uses a quartz crystal to determine the timing as well. These are much more faster and are used more common nowadays in timing circuits. So as a summary for the multivibrators chapter, Multivibrator circuits are used to produce free-running clock oscillator waveforms or to produce a time digital level change triggered by an external source. Capacitor voltage charging and discharging rates are the most common way to produce predictable time duration for oscillator and timing operations. An astable multivibrator is a free-running oscillator whose output oscillates between two voltage levels at a rate determined by an attached RC circuit. A monostable multivibrator is used to produce an output pulse that starts when the circuit receives an input trigger and lasts for a length of time dictated by the attached RC. The 555 timer is a general-purpose timer that can be used to make astable and monostable multivibrators and perform any number of timing operations. Crystal oscillators are much more accurate and stable than RC timers. They are used most often for microprocessor and digital communication.